George, what'd you say?
Put basically force pull by the horse has more force because the horse is bigger, so it provides a stronger pull.
Cool. Strongest pull. Does anybody disagree with George? Mario said the girl. She's buff. Like she's yeah. Don't want to run into her in the dark alley.
No.
Okay.
I'll crack her.
You're gonna beat her up by repeatedly hitting her fist with your face. Okay. So, typical force equals mass times acceleration. I'm gonna do this problem. You guys are gonna put your pens down, put your pencils down. You can just watch the way that I solve this one for just a second. Okay. In about a minute, you guys will be doing what we do. Which means that you guys will have to repeat this process. Okay. So, a 50 kilogram student has an acceleration of 3 meters per second squared. How much is the force being applied to that student? Okay? So using my givens, I know that 50 kilograms, 3 meters per second squared, and I know that I'm being asked to find force. So if I'm being asked to find force, I know my units are newtons, the abbreviation is N. That's what I'm being asked for. That's ultimately what I'm going to have to find, right? So if I'm going back to the 3 formulas I had at the beginning, I'm going to choose the one that's appropriate for that. I know that I'm given my mass because I know that kilograms is my abbreviation, so I know this is my mass. And I know this should be my acceleration because meters per second squared or meters per second is the abbreviation, is the units for that, okay? So the work that I expect to see, the 3-point rubric, is that force equals mass times acceleration. That's you choosing your formula, right? Because you're looking for force. 50 kilograms is my mass. I put in for A, 3 meters per second squared. You'll notice that I still use my units. And my force comes out to 150 newtons. That's just me solving the problem. What questions do we have about the way that I solve that? Sir?
For the second step, do we always have to include the units?
I'd like you to include units, especially when we start with a new unit. Does that make sense?
But like for a test, would you like?
For a test, by the time you get to a test, I would accept that if you put this here, that as long as the 50 is your mass, and it's kilograms, and the A is here, by the time you get to your test, then I would accept just this, for just numbers. But I would still need units here, right?
Okay. For that answer, yeah.
Units on the answer for sure. Other questions? Alright, we do. So pencils up. You and your neighbor trying this together. Okay? Here's the last one if you want to model it. Okay? A 100 kilogram football player has an acceleration of 5 meters per second squared. How much force is that player applying? Make sure that you go through the whole process. Okay? Make sure that you go through the whole process. Take your formula, list your knowns, go through your units. So I see George listing his knowns. I see Amy has picked the formula.
I'm done. I've been there. Okay, so. But then we
Where's the work? Backs it up. You know what I mean?
How'd you get that?
Alright. Okay. Stephanie, how'd you do it? Hold on. Alright. Cool. I chose the same one. Okay. Why'd you say it was 100 times 5?
Because it's mass times acceleration.
Cool.
And that equals
500 newtons. On the money. Okay, this time without your partner. Okay? All on your own. This is you do. Okay? Pencil up. Solve it silently. You should hear no talking. If you're no talking, we can compare answers in just a minute. I want to see all the work, just like we've been seeing here. Questions?
No, sir.
All right. A 1,000 kilogram car has an acceleration of 6 meters per second squared. How much force is the car producing? Yeah, I'm gonna need to see you solve that problem, sir. Sorry, I'm using your bag. We agree? Okay. Agree? Good? Got it? Okay. What'd you do first, Jack?
I did 1,000 times 6 because it's mass, it's looking for force, so you gotta multiply mass and acceleration.
Cool, so you picked a formula, made sure that you had what you needed, yeah? Multiplied it out, what do you get as an answer?
6,000 newtons.
6,000 newtons, okay? You're on the money. Now on a test, I can't give you credit for what you've written down, because you have nothing written down. Okay?
Okay, that's written down.
So I can give you 1 out of 3.
You broke nothing?
I give you 1 out of 3. Hey, John, John, John. Okay? He's got it all. He's got it all in there, right? But the rubric is 3 points. 1 for the formula, 1 for the work, 1 for the answer with the units, okay? A lot of you guys are shortcutting yourself on these points. Now, I know that some of you guys feel like to waste your time when the formulas are short like this. But remember that it really favors you when we get back into the bigger equations. And that's coming soon, right?
Yay.
So, assignment 3.3. It should be in front of each of you if I can count, okay? There are 10 problems. You may skip one of them. Okay?
We ain't skipping none.
All right. I like that. I like that.
Adam,
Okay? All formulas must be shown. All units must be shown in each step. So you asked me if we could skip it by the time we get to the test. Yes, we can skip it by the time we get to the test, but not today. Okay? You may check your formulas and answers with your group. You got to ask 2 other people before you can ask me. You may use one of the hint sheets. Odds are up on the walls today. So 1, 3, 5, 7, 9 are around the room if you want to check your work on one of those. Questions? All right. I love stream consciousness thing. Stream consciousness, right? It's way better. Okay? Awesome. Great answer.
Chill, I like to chill. This way.
You're right. You are looking for 1 kg. It's fine. Let's go ahead and do that. Let's teach you.
In the second way, you're just fighting force, right?
Cool.
Fighting force for the game.
No, it's fine. It's fine.
I want to be sure about
I can accept that.
Oh, yeah, but.
Get a better answer, all right?
Yes, I'm trying to do
What else you got?
My bad.
All right. How do you know?
Help number one is a massive force.
Right.
What is a massive?
Wait, it just gives us force though.
Use it correctly.
For number 4, it just gives us force. You're supposed to. It doesn't give us acceleration.
So then it should be.
What do you mean it should be 0? That's the force of 147.
I'm not even on that one yet.
Absolutely. Can you give me just 1 second?
Which one you want, Mark?
I messed it up.
Does that change anything?
Which way?
Good.
Take it.
Ooh, hold on. I'm seeing a lot of people who've gotten to number 4 and are asking me a question, right?
That's what I was gonna do.
Okay, so before you guys all ask me that question, you can go back to your resource sheet. This fine piece of paper that all of you should own and possess and have like made notes all over, right?
No.
And I want you to look for little g, because we're not grown up enough to be capital G yet. Okay, little g on the bottom corner,
I see what you did there.
okay?
That's not funny, right?
Yes, it is.
It's a little bit fun.
See, it's fun.
Okay, the bottom G on your paper, I want you to look at it carefully, consider the units. Think of that as a hint for number 4.
Okay. Because I need to look for that. Can't find little G. Oh, found little G. Oh, I get this. Boy, I remember this from 8th grade.
There you go. Where's your resource sheet? That's what I just said, right?
Oh, gravity. That's what she means, gravity. Yo. I remember.
I don't know what it is.
It's a falling rock, so the gravity is like putting it down at 10 meters per second. I remember this.
Ya cállate, güey, por favor.
Thank you, sir.
Okay, so let's go back to the warm-up from today. Do you have any notes from the warm-up for today? Not really. See how these kind of build on each other?
Alright, bro.
So, these are the 3 variables. What is that? Cool, write that down. What's in your notes, right? What's M? 4. What are the units for? Right there.
You just move a decimal point. That's true.
Capital. Little n means something else, okay? They don't mean to nitpick. Math.
14.
What are the units of mass?
2008.
Keep guessing with this, I'm just gonna kilogram, right? Grams is units of mass, right? That's how system, the whole, all the
What?
questions last chapter.
Oh, yeah, you mask.
The acceleration.
Because it gave us force.
So you know how you, like it's like that. Like for example, if it's not equal to force, you're supposed to divide.
Exactly, and that's where, because then he gives you 3 equations you're going to use today in the warm-up. So yeah, so it depends on what you're trying to find, we'll change the math you do. Finish your question?
Yeah, thank you.
Triangle, with formula.